I'm going to take you through an example of how to complete this assignment. So I've picked a planet, TOI 1749b. This is a demonstration only. This is not one of the planets from this website. And also because I'm using this as the example, you cannot use this planet. So there's no reason to use this planet. Now, I've already went ahead and entered the screenshots from the app here on the data. The data of the screenshots. I think you know what I'm trying to say. Okay, I've got more data down here. So we're going to start with the potential for liquid water on the surface. We are looking for how much of the star is in that habitable zone. So we go down here, and I'm going to go ahead and mark this one in blue because that's how it's keyed on there. The planet is in here. This is not good. This is too hot for water because it's in the donut hole closer to its star, so we know it's too hot. And I'm writing on this piece of data what it means so that, when the teacher grades it, the teacher knows that you know what this means. So too hot for liquid water. And then up here, I'm going to circle inside the donut hole for more than 5% of its orbit. Okay. The next one is whether or not the planet has metals, rocks and mineral resources, and like a solid surface. The first piece of data for that is the planet density. And does this density fall into the range of rocky planets? Okay, there's two things I want us to look at here. First of all, down here on planet density, its density is 124.8 grams per cubic centimeter. This is not good. Now I'm going to take that 124.8 grams per cubic centimeter and come back up here. I'm going to circle this in brown because this is in brown. And I'm going to rewrite the data value here. 124.8 grams per cubic centimeter. I'm rewriting the data to make it very clear and easy for the teacher that the teacher could see, hey, this is the data number, and that is more than 8. So that's why I chose this rating. Now, another thing that I want to include here is that this type of planet, because what we're really looking for is, does it have the density of a rocky planet? We want a rocky planet. This is listed as a gas giant planet, which is not good. Now, we'll also take a moment to go, what the heck? A gas giant planet should be less dense. So how in the world is this gas giant planet listed with such a high density? I am going to admit to you guys, what? That really doesn't make a lot of sense. But we're going to go ahead and mark that in here because this is pertinent to know. Also, it's a gas giant. Okay. Now, I also want to take a moment to pause here and go to the app to show you, to remind you of something. The density, as you can see right here, let's put it at the top of the screen, I have it listed in grams per cubic centimeter. It did not come that way. It was originally listed as units of density of Jupiter. I had to tap on it until it got to grams per cubic centimeter. I want you to do that for everything. Make sure it's in the correct units of measurement. Do that for everything before you take your screenshots. Okay? That might end up being the only one that you need to change, although these ones for mass, I changed to Earth masses, and I changed the radius to Earth radii, just comparing them so we know how these things compare to Earth. Okay, but make sure your density is in grams per cubic centimeters. Oh, I'm sorry, I also wanted to show you while I'm here. This particular planet, the image for the green donut for the habitable zone, it doesn't show up. When that's the case, you need to click on it, and you either have to zoom in to find it, or in this case, zoom out, then take your screenshot and stick it in the app, in your document. Okay, the next thing we're looking for is stellar metallicity. And what is the metallicity of this particular star. We want somewhere between a -1 and a +2. This one is in gray. Here's the stellar metallicity values. I guess I'll go with that gray. Anyway, stellar metallicity is right here, a -0.26 is actually in the reasonable range. And I'm going to take that up to here. This color probably won't show up. No, not really. Let's go ahead and make sure that all of this is dark enough that the teacher, i.e. me, can see it. Okay, that is in the good enough range. It is -0.26 Fe to H as an iron to hydrogen ratio. -0.26 is less than +0.2. It is more than a -1, so it falls into that good range. Please make sure, I told you this in another video, but I want to remind you this is a +0.02, that's -1 to a, so like a dash. It is not meant to be a minus sign in this case. Anyway, -1 to +0.2. Okay, stellar mass. We want a range of, it's kind of a yellowish color, 0.5 to 1.2. Stellar mass is good to go because it is 0.58. So we're gonna put that in here, 0.58. Solar mass unit, so I'm going to remind you, I've taught you this before as well, but the capital M with that perfect circle and a dot means the mass of the sun. This down here says solar masses is another, just writing it out in words, but is the same thing as capital M with that symbol. Okay, so we're good there. And I'm saying good as in it actually has a good rating. And remind you, the just right category, the middle rating is the good one. Okay, climate stability. Does it have an eccentricity that is less than 0.106? And that was, sorry, what color is that? Kind of orange. Eccentricity, there it is. And that's a somewhat orange color. Its eccentricity is right here. This is too much. It is more than 0.106. It is more than 0.106, so that's going to go up here. It is too much, and I'm going to indicate that it is 0.1400. Okay, can we grow food here? So we got to check the temperature and the orbital period. The temperature, which we will indicate in green. Make sure on this one that you are getting the planetary temperature, not the stellar temperature. That's not what we want. We want the planetary temperature. The planetary temperature comes in at a whopping 831, give or take 18 Kelvin. Whew, that is way too hot. 831 Kelvin. I'm just gonna make sure it can be seen. 831 Kelvin. Too hot. Orbital period, we want more than 260 days. Its orbital period is well, we can round that to 2.4 days. Not good enough. Oh goodness, what was it? Like 3884. I'm going to specify that it's Earth days because those are units of 24 hours. Not good enough. Now, technically, this line, this particular minimum length of growing season, 1/4 of orbital period, was a moot point because this planet was already not in the habitable zone. This piece of data only applies for accuracy if a planet is in the habitable zone of a star that is in the mass range that we want. Our star is in the correct mass range, but our planet is not in the habitable zone. So this was a moot point anyway, but we went ahead and did it. Okay, so now I've analyzed all my stuff. Look at this. Not good enough. Not good enough. Good, good. Not good enough. Not good enough. Not good enough. All together. Heck no. This planet is not habitable. So real quick, take a look down here. My claim, evidence, reasoning. Went ahead and wrote it out. My claim is that this planet is not habitable. Not habitable. Folks, when you do your assignment, if you find reason that your planet is not actually good enough to go to, then make sure that you correctly claim that it is not where we want to go, that it is not habitable. If it does actually seem up to this point that it could be habitable, then you would say that your planet, whatever its name is habitable. Okay, then I went through here and broke down 3 pieces of the evidence and the reasoning. It's a hot Jupiter. It says gas giant planet. Guys, because it's a gas giant and it's close to its star and it's too hot, I know that it is, in fact, actually a hot Jupiter. It also has an unreasonable density, so it does not have the density of a rocky planet. So my reasoning here for those as evidence is that, yo, dude, we need a rocky planet. Surface to stand on, things to build on, things to farm in. We do not have that. So that is my reason that that evidence tells us this is not a good planet. Next piece of evidence, it's in the donut hole, so it's too hot for liquid water. Reasoning, life as we know it depends on water. We cannot survive on a planet without water. So that's the evidence. This is my reason to say, not habitable. I also said for, growing crops, its temperature is too hot for crops. Its temperature is too hot and its orbital period is 2.4 Earth days. So even if there were a colder season, that season would not last long enough to grow crops. So there's my data. My reason is, yeah, we need to grow crops. We need to eat. And this planet does not have the capacity to allow us to eat. Then I wrote a conclusion. My conclusion basically restating the claim. It is not habitable. We should not attempt to live there. Then I included a description of what it'd be like on this planet. It is too hot. There's no chance of liquid water. We couldn't even stand anywhere because there's no ground. The star might have a reasonable mass and could possibly have enough metallicity to allow for a rocky planet, but it's not. It's most likely a first generation star because it has hot Jupiters in orbit. Refer back to our previous solar system notes about why we know there would not be hot Jupiters in a second generation system, and go on about that. That could get you some extra wow points on your analysis here. So then anyway, all in all, this planet and this solar system in general is just not for us. Now, get your project